Hello, I'm Mrs. Repasky. This is a lesson on single replacement reactions, an activity series among 4 different metals: aluminum, copper, silver, and tin. To represent the elements, I'm using an egg carton to represent aluminum, an orange marshmallow to represent copper, an S-shaped piece of styrofoam to represent tin, and a cotton ball to represent silver. In the reactions that you saw in the lab, all of the metals were combined with chlorine. I'm representing chlorine with a dried cranberry. The chlorine is not part of the activity series. It is just the element that the metals are going to swap and try to react with. When you're considering balancing your equations, each of the metals combines with chlorine in a very specific way. Just like sodium combines with chlorine to make sodium chloride, your table salt, okay, this is always NaCl every single time. So every place you go and you put salt on your French fries or salt on your pretzel or whatever you like, it's always NaCl. So every other metal, all the 4 metals here, they combine with chlorine in a specific way. So you have to write their formula in its specific pattern every time. Aluminum chloride is AlCl3. Copper 2 chloride is CuCl2. Silver chloride is AgCl. And tin 2 chloride is SnCl2. In the single replacement reaction, that is example number 6, copper atoms combine in a solution of silver chloride. This reaction happens because copper is more reactive than silver, and copper 2 chloride is produced, and silver atoms leave the solution and settle out and make a sparkly metallic deposit. When you're writing the balanced equation for this, copper is represented as Cu, silver chloride is AgCl, copper 2 chloride is CuCl2, and silver metal is Ag. Considering them here, you can see that this is not balanced. On the reactant side, we have 1 of each element, 1 atom of copper, 1 atom of silver, and 1 atom of chlorine. On the product side, we have 1 atom of copper with 2 chlorides, and we have 1 silver. So comparing this side, which are the reactants, to this side, which are the products, we see that the number of craisins don't match. The number of dried cranberries represent the chlorines. So if I want to balance, you might think, well, I need another chlorine. Well, in this case, the chlorine isn't alone. We can tell that the chlorine isn't alone because there isn't any gas, right? And chlorine has a yellowish, greenish color, and that wasn't present. So whenever we want to add more chlorine, we've always added it as silver chloride. So if you want to multiply one of the elements in a compound, you need to bring its other buddy elements along. So in that case, in this particular situation, the buddy element is silver. So now on both sides, the reactant side and the product side, I have 2 chlorines or 2 chloride ions represented. 2 chlorides here on the copper 2 chloride, and then I have 2 combinations of the cotton ball and the dried cranberry, which represent 2 sets of copper 2 silver chloride. Now I have 2 cotton balls or 2 silvers on this side, and I need 2 silvers over here. This time I can just take another cotton ball and put it in because silver is a metal and it's an individual. So in this particular balanced equation, it's 1 copper, 1 Cu, 2 AgCl, 1 CuCl2, and 2 Ag. The second example that I'm going to do here for balancing is number 7. Number 7 is the reaction between aluminum and copper 2 chloride. So aluminum and copper 2 chloride. So aluminum is the eggshell. Copper 2 chloride is the orange marshmallow with the 2 dried cranberries. This reaction happened. Aluminum chloride is AlCl3, so that's the egg carton with 3 dried cranberries on it. And copper as an element, sometimes you can see it have an orange or a pink color, sometimes it has a brown color. Right? It's coming out as an atom. It is less reactive, so it is going to be alone. So considering balancing this, again, the dried cranberries give it away that it is not balanced. Since the chlorine is always combined with an element in order to balance the dried cranberries, we need to always have them in their compound form. It doesn't matter if you start by balancing the aluminum chlorides or if you start with balancing the copper 2 chlorides. So since I grabbed it first, I'll add an additional aluminum chloride. Okay, so now I have 6 total dried cranberries because every time I take an aluminum chloride, I'm going to have 1 aluminum atom with 3 chlorine atoms, or 1 aluminum ion with 3 chloride ions, because that's its definition. Remember, just like table salt is always NaCl, aluminum chloride is always AlCl3. Right. Now, to continue balancing, if I look at my aluminum, since I have 2 eggshells over here, egg cartons over here, I'll need another one. I can balance the aluminum just by adding an additional egg carton, because metals are individuals. They don't like to buddy up. Right? But in a compound here, when we're thinking about our dried cranberries and our chlorine, chlorine isn't alone this time. So we always have to add one of the compounds. On the reactant side, the chlorines combined with copper. So in order to get 6 chlorines, I need to have 3 sets of copper 2 chloride. So now on the reactant side, from the copper 2 chloride, I have 6 chlorides, 1, 2, 3, 4, 5, 6. And on the product side, I also have 6, 1, 2, 3, 4, 5, 6. I have 2 aluminums being produced and 2 aluminums going in. Now the only thing I don't have balanced are my coppers, which are represented with the marshmallows. Copper is a metal, and metals run around on their own, so those I can just add with marshmallows. Okay? So individual marshmallows. So now I have 3 and 3. So when this balanced equation is written, on the reactants, I'll have 2Al, 3 CuCl2. On the product side, 2 AlCl3 and 3 Cu for copper. So when you're writing your other balanced equations, remember that the metal is always alone without any subscripts. And remember the definition of the particular metal's formula. Okay? Remember what its compound is. Copper with chlorine is going to be CuCl2. Aluminum with chlorine is AlCl3. Tin with chloride is SnCl2. And the silver with the chlorine is AgCl. Thank you for watching. If you have questions about writing your balanced equations, please ask for help. Thank you.